to open house of IIIT Emphasis Rise 2023. We welcome you all, especially our director of CAIR, our deans, registrar, and the faculty members present here, along with the students from different other colleges that have gathered here. Thank you very much. I now invite Professor Das, our director, to say a few words before we start the keynote.
Very good morning and welcome to IIIT and Emphasis Rise 2023 programs of Open House of IIIT-Bangalore. As you know, the RISE stands for a very important elaborations which we talk about internally and with our partners. So R stands for the research, innovations, and entrepreneurships. But there is in between, there is a word called society. Anything we do for the society. Society has multiple parts. One is we ourselves as a human beings, and also the ecosystem. Because without the ecosystem, the society may or may not exist. So all our works in the research and the translatable research out of the research which we bring back to the industry, or to any other organizations, are leading to helping the society. I want to thank Professor Shiva Malapaka and his team who worked tirelessly over the months to organize these things. Thank you, Professor Shiva, who has been the instrumental for this kind of activity, which without them it would have been possible. And I also want to thank my colleagues, Dean R&D, Professor Srinath, and Dean Academics, Professor Chandrasekhar, Registrar, Commander Sridhar, and my fellow colleagues, Dr. Milind, Dr. Ashikant, Dr. Manisha, and all of them are sitting, Venu and also the students and the volunteers who have been working on this. After this keynote, who will be given by an eminent scientist, Dr. Rakshit, Subrata Rakshit, who is the director of the CAIR, Center for Artificial Intelligence and Robotics, one of the leading research lab in the areas of AI and robotics and security in this country. And also they are very much well known across the globe. And he has been working for a long time, which will be introduced by my colleague. And I know them from very closely because of my association with the multiple projects in the CAIR and the world-class research and the deployment they do, and also they help our Indian defense to be really defense and sometime also in the offense if required. So thank you, Professor Dr. Rakshit, for your time and visiting us for your keynote. And with this note, I want to stop at here with welcoming all of you to this RISE 2023, where after the keynote, go to the first floor, and there is an experience center built there for you can see all those things, what we are doing in the last few years. Thank you. Over to Dr. Shiva.
Thank you, sir. Thank you for those kind words. Now, it's my privilege to introduce the keynote speaker today, Dr. Subrata Rakshit. He is a alumni of IIT Bombay with engineering physics degree and completed his MS electrical engineering and PhD in image processing from Caltech, USA. He had a short postdoctoral stint at Washington University Medical School, and he joined CAIR DRDO in 1994 and has been working in various capacities and currently is the director of this particular institute. His particular interests are in computer vision, and they worked on multi-sensor data fusion and net-centric warfare, participating in various Army TAC C-31 development projects. But he is not talking on any one of those things here. He is currently going to talk on predicting the unpredictable, convergence, divergence, and coexistence of humans and AI. And he insisted that these are his personal views, so I am repeating the same. Thank you. Thank you. Welcome, sir.
Good morning, everyone. At the outset, thanks to Professor Das and Professor Shiva for inviting me and coordinating this. And I have to say that this gives me a fairly unique platform, quite different from all the serious defense and project-oriented presentations and assessments that I normally do. And over the course of many decades of working in this, you also end up with certain personal viewpoints, realizations if one might, but which don't necessarily tie down to any formal expenditures, milestones, goals, those kinds of things. So as one of my predecessors, Dr. Naik, used to say, this is from ye dil se, not Delhi se. And in the context of AI, let me embellish that a little bit by saying, dilo dimag se, not daftar and Delhi se. So with that disclaimer, I would like to get into this talk. The reason I said that this was a unique platform is because this innovation and social and entrepreneurial aspect was built into the forum itself. And I thought what better than this forum to interact with youngsters and even the seasoned professionals in the field to talk about some of the things which are not otherwise always getting talked about, but which I believe are foundational and should be addressed, rather than us doing something with a very restricted point of view and blundering into a situation which is not to anybody's advantage. This talk is going to be in different parts. Firstly is what should be more familiar to most in the student community, academia and faculty, the technical aspects of some of the aspects of AI. That just to give a overall coverage and to bring out the width of the canvas that we are really talking about. Subsequently, I'll get on to what happens beyond that core technical part of AI, which is the immediate focus. And that is coming to the managerial aspects, the governance aspects, so on and so forth. And eventually, I'm going to throw all caution to the winds and take on the more esoteric things of saying that given that humans are intelligence and now we are suddenly introducing something else called artificial intelligence, how's that dynamics going to work? What ought to be the positive goals that we should set ourselves and what ought to be the trouble spots that we need to think twice and negotiate? So starting with the first part, as far as the manifestations of AI are concerned, see, within the domain, people who are working on the field will be very familiar with their individual domains. One of the things I find is that when you go beyond the academic and research community, and if you just talk about AI, there tends to be a tendency of oversimplifying what is AI to be whatever happens to be the biggest and loudest buzz at that point. So at some point, somebody would have said that, oh, deep learning based object recognition is all the what AI is all about. Before that, it might have been that an expert system is what AI is all about. Today, it might end up being ChatGPT 3. Now, somewhere we have to consciously prevent that unnecessary narrowing down and keep in mind that AI is going to manifest itself in various different ways. So there is, of course, the text, speech, and natural language domain, where because that is what we humans use for communicating with each other, if the machines have to participate in that conversation, discourse, interaction, then all of this becomes an important branch of AI. Then we are, of course, visual entities. So we interpret a lot in terms of the imagery that our eyes pick up, and consequently we would like images and videos to be processed by the machine in similar ways. Quite apart from that, if you are simply just moving, the third point is nothing necessarily new. In fact, it actually happened much before we got success in text and images. But the fact is that as far as humans are concerned, while we are extremely good with language and with visual inputs, a human being, if given, let's say, a multidimensional feature vector ensemble and asked to say something about it or do a classification task on it, will collapse badly. So even though it's a low-hanging fruit, in terms of being able to do something that humans find hard, we should not forget about the third bullet. And in defense as well as in, say, medical or anything else, there will be cases where that is in fact the more natural way of looking at a problem. everything doesn't have to be reduced to a visual display or a audio tone. Besides these which are typically of the classifier variety, there is also scope for a lot of work in planning, search, optimization, satisfaction problems, so on and so forth. And the leading example of this, I would say, would have been, for example, let's say just the Google search interface. One would have been to just do the hard work of cataloging everything on the internet, but to be able to respond quickly with a search response to a search. If a human being was giving that kind of answers that fast, no doubt we would say, like, that's an oracle with an awesome brain. And you would end up doing the same thing now if instead of a search retrieval based on what is already there, it is further digested and given to you as a chat GPT output giving a conversational interface. So those are still open-ended areas. And finally, there is the strategy discovery, where we are addressing a set of problems where a well-known context exists, certain rules of engagement exist, and it may be a cooperative situation or it may be an adversarial situation, and an individual or a team's payoff needs to be improved by picking on some policies. Typically, RL is the example that will come to all of our minds in terms of AlphaGo and such things. But in many of these cases, we don't necessarily need to go to the pinnacle of the field and beat the best of human beings to be able to claim that that is AI. That is what has been the eye-catching, media-driven spotlight on AI, that, we never really learned to play chess till such time as we went and beat Kasparov or something like that. But let's face it, the chess playing capabilities were good enough to beat your average human chess player a long time back. So in each of these, we have typically tended to talk about it as an AI only when we beat the best of humans. And in the social impact part, that has to be kept in mind, that there is a huge difference between grabbing the media attention by beating the best and being able to do a value add to society because you have already reached, let's say, the 40th percentile of the human population. And those are actually much easier to do than to go for the 99th percentile. Now, why is there suddenly this huge hue and cry about AI? And who should know it better than me? Every company wants to talk to CAIR because we have the AI thing. Every student wants to come to CAIR for internship because, hey, we got AI in our name. Now, forget about CAIR. Even if you were to look at the world in general, from say 2000, 2005 onwards, the hype has been picking up. It's getting to be a crescendo. So I was retrospectively, I was reflecting that what led to this sudden outburst. And as people in AI know that we've had these springs and winters and summers, and people will draw that up and down graph, connections, MLPs, various things. So if we want to understand what has triggered it and to know where to go, we need to get some view of this. So it seemed to me that three things came together. Number one was the scaling up of old tricks to match human performance. So yes, there was a perceptron, Rosenblatt and all way back 60s, and fine. It didn't impress too many people that you could draw a line and separate the 2D plane into two parts. The same principle, but now you take it all the way to a multi-layered, nonlinear sets, and you trained it with a huge number of data and things and of that sort, and you start giving a human-like performance to the system. Now people sit up and take notice. So effectively, so long as you have complex inputs which a human would struggle with, so long as your output space is also complex, so it's not just a red light, green light kind of scene, though sometimes that might also happen. And it turns out that your mapping or the solution that you're looking for is based on fairly complex priors and state-dependent solutions. This is the class of problems which if you actually solve, people will say that if a human had to solve it, the human had to be intelligent. And therefore, by induction, you can say that what I have built is AI. And effectively, the sheer scaling up that we have been able to do in terms of the amount of digital data we gathered, in terms of the number of cores of CPU we threw at the problem to do the learning task, we actually started beating the humans. So way back in high school or in physics or whatever, you would have learned that yes, there are physical things like length, time, mass, but you also need to have a unit. You can't just talk of mass. You have to say it is 1 kg, 2 kg, 3 kg. So if you are talking in terms of the ability to solve this first sort of problems, you also need to have a unit which says that it is what? And the most intuitive unit that you can think of is the performance of an average human with a reasonable amount of training. Now, if you take that as your 1.0, then previously in the 60s and 70s, we were down to 0.1, 0.2s, and therefore nobody gave it much. I mean, socially it was not considered as being a breakthrough. But once you started zooming past that 1 to 2.2, 3, 10, now it suddenly begins to have a huge impact. And in many of these things, we have come to the point where your average trained human being under conditions of stress would not be able to do as well as some of these machine systems can do. So now we are talking an AI that can no longer be ignored from a social and economic point of view. And I believe that was one important factor to the AI storm. The second is this headroom in ICT systems. So if you see the kind of systems we humans have been building, so initially they were purely mechanical systems. Then you started having an option of putting some energy source into it and you had a moving system. Then you started putting electrical sensors, so it had a certain way of interacting with the environment, those kinds of systems we were building. Now eventually the electronics gave way to having a certain amount of compute and memory, and you started putting embedded software into many systems, whether it was defense or whether it was commercial. That is when you started entering the software-defined world. Why was it software-defined? You still needed the electromechanical and sensing as a base platform, but most of the feature add and the value add was coming because of the features and capabilities you were putting into the embedded software of the system. And that is where things started getting interesting in terms of TVs, washing machines, calculators, programmable computers, whatever. Now, it has come to the point where that headroom has increased to the point you can actually start putting some of these quote-unquote AI-level solutions into it. So just as we had a very long period of mechanical design, then a relatively shorter period of electrical actuated powered systems, then an even shorter time span in which we suddenly went into the software-defined business, I believe eventually we'll end up rushing into an AI-defined world, where little bits of AI across all those 5 spectrums, depending on what is relevant for a particular application, will start getting inserted. The headroom exists. So if you are in a competitive business, why would you not want to exploit that headroom in terms of compute, memory, and communication to be able to put some AI-based features into your products? It will drive the competition to do so. Once that happens, this is going to go all across the place. So this software-driven, software-defined everything will very soon graduate into an AI-defined everything. And that's going to be the second reason for this perfect storm. The third one, and that's where the controversy might begin. What is the prime driver of AI? What's its prime demand? It's human stupidity. The fact is that we are creating a world that is rapidly becoming more demanding and more complex in terms of the load it is putting on our brains. So, in terms of the sense of inadequacy and the desire for somebody to bail us out at an individual level, and when I say masses here, I include even myself. I mean, I may be good at my field, but I'm not good at everything. So I'll still be stuck trying to figure out how to use, say, online shopping or how to deal with my mobile or my TV. So eventually, all of us are getting to the point where we want to say, look, I don't really have the bandwidth to understand and nerd optimize everything in my life. So if you do an auto update, that's just fine. You do an auto setting, that is just fine. Just make sure I can press a button and watch the Netflix movie I want. The rest of it is somebody else's headache. I'm just fine with it. So this is what is going to drive the consumer side expectation with respect to AI, not necessarily because we are doing some whiz-bang AI that was, computationally a brilliant breakthrough, but simply because in modern life, the rate of progress is defined by the rate at which the brightest mind can progress. Human gene pool cannot keep up with that rate of progress and make the entire population get more and more intelligence with every generation. Our education system is reaching its limits. How much more can you teach a human being in the 12 years of school and 4 years of college? You are reaching the limits where people are anyway not really able to get what is being taught to them. So we are going to offload it into that AI. And this is going to drive the AI. So keep in mind that all of these are going to be driving the AI, and therefore the opportunities which exist for innovation and entrepreneurship are enormous. You don't necessarily have to go after the highest hanging computationally complex tasks at all. There is a set of people who will be chasing that, and well, they should. That's what the brightest people are for. But AI can actually become a far more broad-based participative endeavor, both in the production side as well as on the consumption side, than where it is now. So, I'm going to give you various perspectives. So, given the crowd that is in front of me, the first one is, of course, the developer's perspective. That why would, as a developer, an engineer want to get into an AI space? And that's a very real thing, by the way. I mean, in DRDO, we have 52 labs. CAIR is the only one which has AI in its name. But we have already had a corporate decision which says that every major system lab will actually have AI as part of its portfolio. So if DRDO is forced to do that, I'm sure it's going to happen across the spectrum in industry and other major verticals also. So first thing is, why would a designer, therefore, who, let's say, for whatever reason went to the CS department and therefore didn't do any formal course in AI, but nevertheless they are going to be called upon to utilize AI. And these are the three reasons. Number one, AI can be a very good design tool. So many of these numerical methods which we have for finding solutions, optimas, model building, so on and so forth, if you had done it any other way, you could not have done it. Way back in my college days, we used to have lectures on linear filter design. Okay, fine. So you had a shift invariant system. Eigenfunctions were the Fourier harmonics. So you did low-pass filters, high-pass filters, notch filters. I mean, you could take that approach only that far. Remy's pole zero exchange was just about the limit of it at that point. That's it. Now, if someone suddenly said, forget about one single filter design with pole zero. I want you to design a bank of filters. They should be nonlinear, and I want a cascade of these nonlinear filter banks. Now can you sit and solve it analytically? No chance. But if I say that, can you therefore train a deep network for doing it? Absolutely. Just throw it into the latest package and out comes a result. Okay. So in terms of where the numerical designs can go, quote unquote AI is going to be the way many of these designs get extended. At that point, you are using AI in your design space. You are not unleashing it on the customer. So you are doing a chip layout using AI, or you are doing any of these MIMO optimizations or whatever, and you are using some AI to find a better solution. The customer is not getting the living, breathing AI that you put in. They are getting the output that you are giving as a static design, but you used AI to get to that design. So that would be one reason. The second thing is AI as a software-defined variant factory. So whenever you solve a problem and you solve a class of problems, as a designer, you would like to, quote unquote, come up with a generic solution for an entire class. Your clients and customers, everybody believes that they are unique. They don't want to be told that they are generic. Okay? So everybody will want a certain specific solution. No, I want it customized for my need. I want this variation, that variation. Now in the software world, you could actually do that. You could not possibly do that in physical systems. So if you are, let's say, going to a car manufacturer, you will get LXI, ZXI, some platinum, that's it. I mean, they will define some 3 or 4, that's it. On a hukum basis, they cannot be reconfiguring their production line to come up with 10 numbers for something without astronomical costs. In the software, everybody said that, however, software is only software. What is there? You go into that, make some changes, hit that brown exclamation mark, out comes a new executable, and you are happy. But we all know that it leads to huge problems in version control. It's huge problem if you want a software engineering stack of IVNV, VAPT and everything else running on top of every variation that you make. So if you are changing the code at that rate to create variants, you are going to be in trouble. On the other hand, If you have incorporated a certain amount of AI, it means that every time a customer comes with a requirement of a variant, you simply take that data, retrain a certain fixed set of numerical parameters, and all said and done, the control plane doesn't change. It's only the configuration space in terms of the parameters numbers that have changed. And now you have created another variant. So creating variants like this may actually be more sustainable for any engineering design team than actually going with code changes. So this could be another reason why in days to come, developers themselves, without being asked, would want to on their own go ahead and plug AI into their strategies. And finally, there is this question of stationary versus non-stationary environments. Just as linear is a engineering idealization because we could not have done an analytic attack on a non-linear world. Similarly, this business of stationary statistic is an idealization that we engineers came up with. In practice, nothing in the world is truly stationary in that sense. So things will keep changing. One thing you can say is fine, then every now and then you come to me, I will give you another upgrade, and so it goes. You could. And if that upgrade had to come all the way back to the designer and the OEM, it would effectively go into the second variety. But you might at some point get bugged with all of that and say, no, it's waste of my time to do that. You could actually put a training module into your solution itself. So every now and then it will accumulate all the mistakes it made or the latest inputs it got, retrain itself, and hopefully become more suitable for that particular application. So if you have a distinctly non-stationary environment, AI would be the way to go as a developer. So these would all be the reasons why developers, engineers in various fields should be looking seriously at AI and adopting it. And as AI specialist, you could embed yourself in the design teams of just about anything and say, look, this is the value add I will bring. So that's your ticket for getting that job or getting that role. Now, up to that point, things are more or less in the technical domain of the CSE departments, so on and so forth. Now we are going a bit beyond that. From the management perspective, we are woefully unprepared for this AI storm breaking out. Because in many ways, AI is breaking the fixed expectations and molds, and it is leading to chaos. It's leading to disputes, it's leading to payments being held up, it's leading to requirement analysis going on forever without ever converging, all kinds of things. And especially if you work in the more formal sectors like defense, it hits you more. If as a startup you are saying, look, I will build whatever I can build and let me see if I can get a customer for what I have already built, it's a safer experience. They are getting what you are giving and that's it. But if you had to do it the other way around, the customer comes and tells me that this is what they want and now I want to build it and hit that target point, then you will realize that the way we are practicing AI is not very good at doing that. So part of it I will explain later on, that the traditionally we had a certain practice for acquisition. If I wanted to buy a computer or a desk and a TV, whatever, I did it one way. I had a different approach when I was doing hiring. So you would not, except for the rare case of, let's say, doing a lateral hiring or whatever it is, whenever you do a hiring, you evaluate a certain potential in the person. You are not hiring based on an input-output validated function or an ATP, so to speak. That person is not going to answer every question in the interview. The person is not going to say, I aced 100% in every subject I have taken. And you would allow for the fact that that person is going to require a certain amount of on-job training, and you would have a management overhead of looking after the newbie to make sure that the integration into the organization framework has happened. Those were the things which management took into account when they hired. So they would not expect that here is a set of 10 freshers off the campus and from tomorrow onwards they are project managers. Of course not. And neither will anybody say that NDA cadet can become a brigadier tomorrow. Of course not. It takes another 20 years. We took that into account. It is turning out that these AI things are falling somewhere in between, and we need to tell them that an AI cannot work out of the box necessarily any more than a cadet or a new hire can work out of the box. So I'll go more into that later on. And why is it that the traditional practices are getting hit by AI? So here is just the chain that, so if you look, the current chain is something like this. There is a certain protocol that is there between the customer and the OEM for signing off on requirements. Then it comes to a requirements design, then there is a development, there's a testing, there's a certification, there's a training, there's a usage, there's a maintenance, it goes on like that. Now when it comes to the AI part of it, things go backside front. Because how do you define the requirement? If I simply say my requirement is voice recognition, it simply is not enough to drive the next step. Whose voice? Under what condition? So a one-line text saying voice recognition is not going to lead to an engineering practice unleashing itself. So it ends up that you need practically this data that you would have used during testing and certification to be even present as part of a requirement itself. And that is counterintuitive. If let's say I'm buying a radio, I will say that I want at 20 kilometers line of sight 1 Gbps on the channel. It is never going to be the conversation, it is 1 Gbps if I'm sending you a map, but it will become half a Gbps if I'm sending you my payroll XLS file. That's not the way it goes. But if you look at even the best of the papers being published on AI, it is always with respect to percentages on a given data set. You change the data set and all bets are off. I did it on Caltech 256, I got this number. I do it tomorrow on CAIR 1024, I may not get the same number. And AI people expect it. But the management people are not used to that. So it is leading to issues with respect to integrating AI practice to established corporate practices. And this in itself was the subject of a full-blown talk I had given at IIT-Bombay. I don't know if it is there somewhere. So how would you map AI approach to requirements, AI approach to design, what it means to do the development and testing, what is reasonable expectations? Because again, if you said that it's exactly a particular input-output training data and that is what I'm going to use for testing, a cheater could just use a lookup table and then where are we? So you can't allow that to happen either. So there are technical issues involved in saying that if these are the top-level requirements for fitting AI into the delivery structure in corporate world, what is the expectations from the management we have to create and what are the practices from the engineering side that we need to imbibe? Right now, it's not done. Then comes this business of IPR perspective. Somebody comes and says, do some AI for me, or you say, okay, here is an AI solution. And then the finance sits and starts doing the nitty-gritty, or somebody else comes and does a supervision. And it is not at all clear what they expected in the first place. So after a lot of confused conversations, internally we have come up with this canonical breakup to say these are the pieces which are typically going into an AI, quote-unquote, AI product, and each can have its own provenance, its own costing, its own life cycle maintenance issues. So you have the algorithms which are typically the core of it, the heart of it, so to speak, and typically they are not the ones which are proprietary. People do publish this. So far AI has been a reasonably open field. But an algorithm in its mathematical form is not going to solve any problem unless it is implemented as a software, usable, callable software package. Now we are coming to a manifestation, and this may be proprietary or it may be open source. And somebody may choose to work in this space and say, my claim to fame is I changed a little bit here, and I'm going to inherit this entire package from some existing implementation and just say that, look, I made this change in algorithm, this is the change in the final output, therefore for that pay me so much. Or somebody might say this was as it is, but that implementation really sucked and I've gone ahead and done it on a different platform or different language or better numerical handling. Therefore, that is my contribution to that AI solution. Then there is the question of data sets, because algorithms and softwares will ultimately crunch the data and come up with a model. If you did not create the correct data set, of course, you are not going to get anywhere with your training algorithms. So it turns out that this is not to be taken for granted. Is it big enough? Is it complete in terms of capturing the complexity? Is it clean enough that it is not going to misguide the ML part of it? So practically speaking, a lot of effort and judgment is getting into this and broadly under the heading of data science. So this has to be understood as being an independent component in itself. Then you take these three and you create the trained model. But then again, it turns out there are enough parameters and hyperparameter tuning and everything else involved, that it is not obvious that anybody using these three will necessarily come up with the same model. So people are taking credit for the specific model that they managed to come up with. What choices did they make? Even when you finish this much, and you might think that, that's it, done with AI. Not quite. The comparison I would give is to say that when you do this much, you have created the IC engine of a vehicle. Now, you don't go around selling IC engines to the customers, right? You need to sell them the entire sedan or the truck or whatever it is. So, having created this core AI component, and at this point you would have validated the AI part of the technical risk, saying that could AI current practice or my current knowledge of AI allow me to solve a problem of this complexity? That answer is known when you have finished this. But how do you actually deliver it as a customer experience is you create an end application. And this is where it has the customer interface, the network interface, the databases, the actual porting packages on different hardware platforms, everything else. And eventually it is this which is going to get evaluated by the user to generate a feedback. So your delivery is going to be with respect to this. Under the hood, you have all of this sitting. In exactly the same way, you go into a car showroom, you buy a car, and under the hood is that engine. And except for few mechanical engineering and car buffs, you would hardly ever have gone in and, poked a nose into that. What was your gear design? What was your engine design? We go and say, okay, I wanted to buy an Innova or I wanted to buy a Swift, and I have my way of looking at the vehicle and does it give me the value I want, and that's how I go with it. And it is going to be that complex and indirect even for AI. Now the last part which is increasingly coming out as we engage with our users is this business of feedback. Customers will give feedbacks in general, but since the AI products end up being bespoke products built for a particular person very often, the feedback is also very specific and is driving the evolution of the product, at which point the customers feel that they really own the product. And a lot of in the civilian world, privacy issues, in the defense world, proprietary privileged information issues are arising from that. That having told the experience of using that particular AI product and driven its experience, how do you now say that they have not in effect become stakeholders in the next generation that came out? Maybe they are. But it would enormously complicate our lives if that started leading to financial implications or IPR implications, and that needs to be solved. So that's the IPR perspective. Now, let's say you traverse all of these and you actually got an AI product going out and it's selling like, it's getting deployed. So some bank manager is using your AI product to decide whether to give a loan, not to give a loan, foreclose something, not foreclose something, whatever. At that point, you have this other issue coming in, that first of all, someone will say that, look, I could have argued with the bank manager, but now the bank manager says that the software declined you as your loan, so tough luck. I mean, there's nothing I can do about it. And that's not a satisfactory conversation in the social space. I should be able to ask a question and get an answer. So people said, okay, let us have explainability as a criteria. And I will tell you later on why that is easier said than done. Primarily because that education system in place to ensure that humans can explain things to each other is simply absent the way we are going around doing AI today. So, can you ever get a truly good AI to be explainable to a lay customer? My judgment is you're out of luck. And it's going to be that way for a long time. So, in fact, while that effort is nevertheless on, we came up with a in-between via media called Believability, by which an AI would actually give you reasons to believe its output. So it would say, for example, okay, this is the application that you gave, to which I said yes or I said no. Now, if the bank manager is incredulous, how come this fellow managed to get the loan? Or the customer is outraged that why was I denied the loan? Either case, you can ask the AI, what is it in your training set which was very similar to this that you have seen? Or is it that you did an extrapolation of absolutely insane proportions and you never saw anybody like this before, but you passed a judgment because you were forced to answer a question? Okay, so you can reverse query an AI to say that what were the similar answers, similar training examples to this particular probe case, to say that was the AI therefore familiar with this and should it be trusted. The next question that arises is that even if you were there some similar things were there, were you getting it right in the training set? See, if you look at a human being, you come and ask me a question, I give you an answer which you are finding hard to digest. First of all, you can say that, okay, have you ever done courses in this field? If it turns out you ask me a question in quantum mechanics, I've never touched physics in my life, why would you believe me in the first place? Okay, so let's say it turns out that I did do some quantum mechanics courses. Then another doubt hits you. Did you pass that course? So, I may have been exposed to quantum mechanics. It remains to be answered that did I ace an A grade or did I get a I and then somehow managed to get an E and got away on the 8th semester. Two are very different situations, right? So, in the believability, we were saying that we will talk in terms of the similar things. We will also say that among those similar inputs in the training set, what fraction actually the AI got right. If that happens, the situation becomes something like this. I go to some specialist, say a stockbroker or a heart surgeon. I say that this is the problem I have. Now that person gives me a diagnosis and a treatment. If you are saying that I should quote unquote have it explained and understood, then I'm limited by my poor knowledge of medicine and stocks. So why am I paying the specialist if I'm not going to trust the specialist? So that cannot be the way to do it. And consequently, in human society, we actually look for evidences of familiarity and competence, and then we simply go ahead and believe an expert. So something like that we were trying to do here. Okay. Now, based on this, we would then have to look at what the various regulatory requirements would be. That if you decide that you want to go with explainability or believability or certain ways of doing testing and verification, all of that then should come here, because every individual customer cannot be an expert in all of this to say that the developer got it right. So the way it typically happens is, as a customer, you go to see whether a certain certification rating is there on the product you are buying. You assume that they have done the technical heavy lifting at the back end. There's a social root of trust in some government mandated certification agency. Then you believe it and you buy the product. So all of this we would have to do to deal with the management perspectives yet to be dealt with respect to unleashing AI products in the retail space. Now, the last part is the social part of it, and these are the truly gut feeling kind of things. I see that there is a huge comparison that we can make between AI's humans and actually the education process. In the case of, the first thing I always point out is that who has a childhood? A baby lizard is just a lizard. You don't have a special name for it. But a baby dog is called a puppy because its behavior is very different from an adult dog. So it turns out that once you have a certain amount of cerebral cortex, you cannot be born pre-wired. Therefore, you need, quote unquote, a childhood phase to get it into an adult state. That's where the training is happening post-birth. Whereas a baby ant is pretty much hardwired and it's fine. It may be slightly smaller, but that's what it is. It is not learning anything in the first 1 week of its life. So we have a childhood which allows us to do that. Then we have a culture and education coming in. Now that is where we have very strong supervised learning processes, and they do two things. Number one, they do a standardization across all individuals. So all of us have gone and learned certain languages in common. So if me and you don't have a language we have learned in common, we can't talk to each other, explainability goes flying out of the window. The reason why as a dentist you can explain something to me is hopefully both of us know Hindi or Kannada or English, and therefore we have a conversation. Okay. So the commonality of education as a supervision process in the learning is important for that standardization part. Then there is the question that how fast do you learn? If we had to say that fine, we send our kids out into the world, let them play around, roam around, do whatever they want, and with the big data they are getting, they will learn engineering, no chance. So you actually have an accelerated, directed education approach. In professional life, you say that fine, we have reached the limits of that. Now you go ahead and learn on your own. And ultimately, as my father used to say, who was Einstein's guru? Einstein had to break his own path. So eventually, we all reach a point where we have hit the saturation point of what a directed education can get us. At that point, we are truly doing learning from real world data. But up to that point, as an acceleration, we are having a very guided path. It is not even just active learning, because active learning would still mean that the data was inchoate and as a learner, I was driving the process. It is actually active from the supervision point of view. That is the favor we humans are doing ourselves. Somewhere that is not being thought of with respect to the machine learning. It is almost like saying you are such a bright kid, therefore I'm not going to send you to school, you learn on your own. That's a disaster. And that is why we are ending up that even for the simplest of tasks, you need 1 million data points to get anywhere in life. See, it was great to know that we could get away with that in some cases, where we did have the 1 million points. It's good to know that that architecture is scalable. But to say that that is the preferred way of doing things is not sustainable. And we should start thinking of how we can put our ML systems into this kind of an acceleration. And in defense, we are forced to do some of those things, that you have to start with a model, you have to start with synthetic data, you have to start with limited data from trials. You cannot be going around having 10 wars in order to do an ML to learn how to fight a war. It just doesn't work. And I suspect it will not work for most things. The Google image repositories based on text tagging was a unique case which bootstrapped it. But it's not really a generalizable example. So this part of it has to be figured out. So that's the part that this euphoria of big data and deep learning has got to make way for something which mimics the actual efficient human education system for ML. And this might need a different way of looking at things. And in particular, the signal processing and information theory has to be brought back into focus and as part of the machine learning. You cannot simply say that, no, all of this is old world and 20th century, I will just pump big data into it and get away with it. You are not doing yourself or your learning systems any favor. So this part of it has to be redone. And the initial parts where you have much less data, but where you might have a certain guidance from an expert, these expert systems might be required to create certain halfway solutions, which can then generate the easy data to learn, after which you can go to the prior training feedback and go all the way. And this believability concept, we need to take it through, that it should be built into the way the ML systems are being trained, such that they can come up with these outputs on demand. Now, this is the part that I was saying, that education, on-job training and management overheads, which we are willing to grant ourselves as human beings. But so far we have been very stingy in saying that we are going to do it for the AI as well. And we have equated buying an AI solution to buying a bucket or a mug, and it's just not going to work that way. So factoring the AI into the strategy of each. So two things. One is, if you are saying that this is the way humans are doing it, can I incorporate it into the machine learning strategy? That is question number one. But this is deliberately an ambiguous set of bullets. The other way of looking at it is, we had currently a certain education scheme for our human children. If AI is going to enter into the world in which these kids are going to school, how would it change the education process itself? Now, back in my days, the whole dhoom dhadam was, oh, now that there is a calculator, do I really need to mug up what is 14 into 17? My father took great pride in knowing that he knew 17 into 19 and you only done 8 into 9. Now, I can do the same thing with my kid. There are many things that I spent a lot of my effort doing and he couldn't care less. Spelling, for example. He'll scratch across the keyboard and you are old. Nobody types anymore, he says. So be it. So now, these are the effects we have to get in. That what is it that we want the human to contribute? What we will assume the AI will do any case? Why bother even asking the human to do it? So what does it mean to say that we are doing an education, we are doing an on-the-job training, and we are doing a management overhead in an environment where AI is part of the environment? So all of this would have to be looked at. Now, one huge issue here, is it that the AI is adapting to humans or humans adapting to AI? You cannot stop either of the two from happening. So it ends up being an active system which is going to be prone to oscillations. it's going to be prone to getting into states that were not planned and it just goes off somewhere else. The only theory we have for doing all of this is going back to control theory, which horror of horrors is not in the CS department, it's in the EE department. Okay. Now this control theory had a certain way of looking at things and saying that, okay, there are poles, there are zeros, and so long as your omega 1 is within a decade of omega 2 of the system and the controller, then all your pole zeros go off to the left hand side and you're safe. One of them jokers drift onto the right half plane and you've had it. You either get an infinity or a zero. Infinity means your system goes berserk, zero means it goes dead. Now we might have to worry that if humans are adapting to AI, AIs are adapting to human beings, the government's regulatory mechanism is not fast enough, the social norms are not fast enough, these things will happen. And that is where the downsides of the early adoption of AI will come in. I don't believe it will be fatal for anybody. It will just be non-optimal, and it would be good if you could minimize them. Now finally for the really esoteric part, but then you did put S for society into your eyes. So I'm given the license to show this slide, so to speak. Okay. Equitable society and the utopian ideal. Now when we talk about AI, and various people have gone ahead and either said that, AI is going to solve all our problems, and others have said that's it, AI is going to wipe us out. Now, where do we stand on this now that we have had, say, 10 years of fielding AI? What was the utopian ideal? That, roughly speaking, the picture they had in mind was that genetically there is a distribution of intelligence across the human population. Let's say it is Gaussian distribution, whatever. So some people are at a higher level, some people have got much more, some people have got much less. And somewhere the feeling was that once you have an AI, you can kind of do a handicap like you would do in a horse race and make it equally likely that everybody has got the same amount of intelligence going. So that was the utopian thing. But has that ever happened in the past for anything? Did it happen with education? Did it happen with capitalism? Did it happen with anything? What went wrong? See, ultimately it's a human being who has to be providing that handicap. The question is, do we have enough self-sacrificing, philanthropic human beings who will say, I was at the top of the game, but I chose to spend my life helping the person at the bottom to come up to the top. That power equation just doesn't work out. And most of these things end up going into self-reinforcing cycles. So when you had this industrial revolution and science and technology coming in, did it improve human productivity? Absolutely. There's no doubt about it that we are all better off than we were, let's say, 1,000 years ago. But as the saying goes in capitalism, you needed money to make money. So it was never going to be the case that the steel worker was ever going to catch up with Carnegie or Rockefeller in terms of their assets. Carnegies and Rockefellers went racing ahead. And yes, the steel worker did make more money. They got a car, they got good food, they got a house, fine, great. But nobody ever said that it led to a utopian situation where everybody had the same amount. By brute force, when we tried to do it, people didn't cooperate, and that is what happened in the second world. So ultimately, they didn't get anywhere, not because the theory was wrong, because, okay, you never had that kind of a human gene pool. With AI, the same thing is going to happen. AI solutions are not going to be easy to use. You need brains to use that AI for your benefit. Otherwise, what is going to happen is somebody else is controlling that AI to control you, and that is going to be for their benefit, not yours. So yes, when I'm going ahead and doing a e-commerce or a ticket booking or something, maybe there's an AI in the back end. But to be sure, if the airline company paid for that AI is tasked with increasing the airline company's profit, not increasing my benefit. It might give me the appearance of doing so. Oh, we have found better deals for you, this and that and things like that. But who knows? So it's not a realistic expectation to say that while AI might tremendously improve our productivity, will it lead to a utopian thing? No. Now, I also said I will give you comparisons with the past. Intelligence tends to be a winner-take-all kind of entity. So once you are that much more intelligent than the competition, you will tend to wipe them out absolutely. It is not the case that it will lead to a natural feedback which will suppress. One stark thing to keep in mind, when evolution was happening, we were not the only hominids in the game, by the way. There were 2-3 others. today we are the only one. And though we may not want to publicly talk about it, the fact is that we viciously wiped out our cousins. So it is not the case that there is not a history of an intelligence being badly used. So this history is not very comforting, but hopefully we have now become a more mature species, and we will be, this is at least not looking at some cousins, this is looking at ourselves, right? So whether human beings should have that kind of empathy for human beings, one hopes for the best. So this long-term coexistence to a new normal, one is we would have to survive this transition phase. We have to make sure that it doesn't lead to such drastic winners and losers that some people are completely exploited by the others. And this feedback loops, see, one thing can be that you start creating some AIs which are customized for the really intelligent, complicated people, and some AIs which are meant for as a lullaby to the less gifted individuals. And if both of them get into a self-reinforcing loop, you might actually end up creating a bimodal distribution. And it's not clear that that would be good for us as a whole. So this feedback loops can lead to divergence tendencies in societies, and you might end up with very distinct silos. And in the long term, what effect will AI have in the way we bring up the next generation? For this, I will refer you all to a book by a British historian in the 19th century called Sir John Glubb. And he has this famous write-up, its PDF is there on the internet, The Fate of Empires. And effectively what he says is that all these big civilizations, fate of civilizations or empires, I forget, in about 25 generations they have a rise and a fall. It's very distinct. And it's very typical. I mean, Egypt, China, India, Romans, Aztecs, you name it, all went through that cycle. And he says that in effect, you start off solving a problem. But each generation, when they solve the problem, they present their next generation with a different world to live in. So that generation is not ever a replica of the previous generation. So you don't achieve steady state. And it so happened that so far the way things were going was you were reaching a pinnacle of physical and cognitive capability flourishing in society. But then because of the distractions you created and the ease of getting away with non-productivity that you created, people start getting lazy and one might even say morally corrupt, whatever it is. And then finally civilization goes and tanks. And the drift generation to generation was so characteristic of humans that across all these civilizations, the cycle was having length 25. And he gives very convincing arguments and data and things like that, by the way. So whether it is numerically precise theory or not is not the issue. But we have to keep in mind that whatever we do with AI this generation, the impact it is going to have on our kids who are exposed to AI as a 5-year-old kid is very different. In my generation, for example, after we grew up a certain bit, TV came on. So TV for us was an entertainment in our adult life. It was not a distraction in our school days. But next generation, the TV became a distraction in the school days. Even worse, TV became where you got put by your parent while they were trying to feed you something, or where you just sat there and watched Disney cartoons while your brain vegetated when your parents went and did their work. Now, what effect it had on the next generation, God alone knows. So these are the kinds of questions for AI that has to come up. Last but not the least, there is this business of social distancing. I don't mean the physical distancing that we have been doing in COVID. See, human beings are not necessarily good at getting along with each other. For certain practical reasons, we've had to get along with each other. So there was a socializing process by which, irrespective of our various idiosyncrasies, we would get along with each other. Now suppose you are introducing AI as an interface layer in between. So I talk to an AI and get some services. The other OEM is talking to the AI and getting something else, and all of us are buffered from each other as human beings with the layer of AI coming in the way. It might make us less sociable. And the social distancing in that behavioral space might actually start increasing, simply because AI is letting us get away with it. So these days, for example, if my son is playing games with his friends, they are not sitting together and playing kabaddi and fighting with each other. He's playing some online game, and there is his friends in Spain, in Russia, in Brazil, and they are playing some game or the other, and the interaction is on the mobile. So the socialization which might have otherwise have happened is happening in a very different way. Not that it is not happening, But it's a very different thing, and we certainly as parents never designed for it. So it simply happened to be something or the other, and these are the things that we might need to worry about. And lastly, this business of cognitive toxins. As a society, there are certain things which are obvious to most people. So they know that you eat the wrong thing, you'll suffer the consequences. So if tomorrow you're introducing a new food or a drug or anything else in the market, people will say, okay, what is its kidney toxicity study, liver toxicity study, heart toxicity study, 101 federal regulations, central government regulations, everything kicks in. Now you go ahead and introduce a game into the market. Fine, I mean, there is the usual amount of checks, pretty much irrelevant with respect to, let's say, foul language and nudity. But beyond that, we have never thought that, is it addictive? Is it going to encourage something else or the other? Even at the physical level, see, the human brain is born plastic. You have a mechanism of learning what is your attention span. How do you decide when to get bored? See, if you never got bored, you'd spend your life looking at nothing happening, and that would be a waste. But at the same time, if you decided that if Tom doesn't hit Jerry on the head every 2 seconds, I'm going to switch the TV channel, then also you're in trouble. The natural time constants that we were learning as kids was meant to be crafted by real life. If it starts getting crafted by responses from a IT system, that too driven by AI to necessarily see what makes us want to stick around and do that, things can become physically poisonous for us. And we are not even having the social mechanisms in place to look at that. Many of you who would have looked at extremely fast changing visual displays would have felt nauseated after some time. The reason being that in real world, the whole scene is not supposed to change suddenly. You're supposed to have a saccadic vision which is looking at the details. So there was a certain rate of oxygen consumption that it was assumed between the magno and the parvo channels in the visual cortex. Many of the displays which you would have in cartoon TV, or if you are scrolling through channels or something like that, will violate it. Especially if you are watching the TV and somebody else is controlling the channel. Because then you are not blinking in sync with the channel change. So it will generate a spike in your head that you were not meant to survive. Evolution never trained us for it. So many of these things are getting to be a problem. They were a problem even before the AI came. They'll become far more of a problem now that AI is there. And very often this business of dispersion comes in. In real life, once upon a time, if you opened some channels or opened a newspaper, there would be all kinds of things coming in. Yes, you had some amount of chance of ignoring what you didn't want to read and read what you wanted to read. But with AI coming in, there is a tendency to give us exactly what we have wanted in the past. That might be, in the short term, good for customer loyalty. In the medium term, it is bad for the customer. In the long term, it might even be bad for customer loyalty because you'll simply get bored and switch. So a certain amount of dispersion term has to be built into the way we are doing AI when we are trying to do customer experience. And that has to be either done from a social responsibility point of view, or even from a better strategy, that it will be a more rewarding experience if I actually throw in a certain amount of random inputs just to see whether something else is agreeable to that particular person. So a lot of this is there, and last but not the least, what makes it hard to deal with this is regulatory mischief. In the past, censorship at the hands of a powerful but somewhat malevolent power center has always been a problem that we are worried about. That while it might seem to solve an immediate problem with respect to law and order, in the long term it has led society astray. So we have got this built-in thing that adults should be allowed to do what they want. You cannot babysit an adult. So if you are now trying to say that cognitive toxins are what the problem is, it's not clear that you will not go and hit that as a problem. Given time, some of these things will solve itself. So the first time that people started getting fake news on various social media platforms and all, and it might have had a big impact on some election or the other. But over a period of time, people are getting used to it. People are understanding what the game is. So, and maybe both sides have jumped into the fake news business, so now you are flooded by equal amounts of fake news and the problem has solved itself. So various things might happen, but nevertheless, what was explicit before has become far more subtle but seductive if you start using AI in the presentation logic. And that's the part that I think as a society we have to watch out for. One of the things is, what are the limits of AI? Would AI become the same as human beings? And it always ends up being a discussion on accountability. So these are just some of the thoughts. These are not anything that I've built or tested. That under the hood, what is happening in terms of the human accountability? One is you have traceability, that I can say this person did it. Then there is this implicit business of pain and fear, that I can inflict pain, the other person will have a fear of having that pain inflicted. Therefore, if the traceability exists, that behavior will become different. But in order to prevent its abuse, we also have an opportunity to defend, that I can, I'm not guilty without a trial. And many of us are good at passing the buck. You know what, I did it because he said so, or she stopped me from doing this. Therefore, all of this is under the hood with respect to the actual practice of accountability by humans. Now, if we want to say that we have to have a model for accountability of AI, it's a tricky issue. One way is to say that, okay, that there's a designer, seller, deployer, user, let us say who's accountable for what. That might work, but it would have to mean that for each of those cases, we would have to solve all of those and put it in. And you are still making different humans associated with an AI accountable for that AI, and maybe that's the best we can do. Because it's not clear to me you can actually put pain and fear into that AI. You have built it to be immune to such considerations. So by construct, you have created a logical device, not an emotional device. Now you can't say that I want an emotion in there. Then there is a question of goal setting. As children, we have our goals set by adults, and that is considered the obedient child. Of course, all children are not obedient, but as kids, you get banged for it. As an adult, you are appreciated for it, a self-motivated person. But whoever appreciated a naughty kid as being a self-motivated kid. Now, when it comes to AI, we want to model it for its adult behavior or its childish behavior. The safe thing to do would be to build so-called childish AI. It is supposed to do what is told to do. It is not supposed to do anything else. But then we are personally responsible for limiting it to being a childish AI. If you wanted to do it the other way around, you would have to give it the ability to go ahead after something else and develop secondary goals. Who knows what will happen? You allow secondary goal exploration with constraint. That is actually being done. Many of these autonomous systems and all that are built to do something like that. But again, under well understood physical choice constraints. Not that here is an AI for displaying movie choices to people, and AI has suddenly come up with its own secondary goal of what it wants to do. That sort of thing we have never tried and we have not tested. Another question that comes is, fine, you have solved your machine learning problem, but there is so much more to human beings. And you have aesthetics, beauty, peace, serenity, everything else. Now, my feeling is that if anything was that important and it could be defined, I don't see why a bunch of computer scientists can't nail it. So if you actually set up a specific target to shoot for, we scientists can go and shoot for it. But the problem is that many of these things, we are not even in a position to define it. That's the reason why the AI is not doing it. There is no inherent limitation on the fact that you can't have a gradient descent algorithm achieved an objective function, provided you could write an objective function which maps to our sense of any of these. So, I mean, you would have seen these pictures of how AI is like a, flooding going on and slowly flooding all the peaks out. And eventually these peaks will also get flooded is the judgment. And finally, this business of divergence of goals, that would the AI suddenly go off in a different direction? I mean, but let's face it, it is not that all humans agree where to go in the first place. Somebody wants liberty, somebody wants control, somebody wants discipline, somebody wants chaos, all kinds of things happen. So, I don't think we should be very strict about the AIs not being given the freedom to come up with some secondary goals on their own. Now, some of this might seem rather alarming, but when it comes to a convergence of strategy, there are also certain good things which can happen with all this churn and all this pain. One is that you can get an increased awareness of self by human beings, because criticizing an AI is so much easier than criticizing ourselves. And once you criticize the AI, you can then map it back to what was the equivalent thing for humans and say whether the humans can be fixed. Or you see how we have fixed it in humans and you figure out, therefore, that is how to fix the AI. So this mutual ding-dong, if you keep doing this comparison between AI and HI, I think we can prevent any of these things going off the rails and creating a disaster. As far as the expectations from intelligence and AI is concerned, more or less that will end up being the same, whether it is human or whether it is artificial. There's no reason to diverge from it. And eventually it should actually lead to a uniform regulatory perspective also. I mean, if it is legal for a human to do it, then it should be legal for the AI. And if it's not legal for the AI, it should not be legal for the human either. And so right now, various things are going on. Part of it is to do with the fact that human beings are in the physical world and in a position to do actions and gain knowledge which is unique to them. So for example, when there was this model learning based on huge amounts of copyrighted material. Now, if you look at it in the education process, everybody goes to college and learns from the masters in any case. But somebody who went to music school, came out and played a new piece, was never accused of copyright violation because they learned from Bach and Mozart. But when they did it with an AI, then suddenly it became a lawsuit. So these are some of the things which, if you ask me, will eventually get ironed out, and it needs to be ironed out. And last part of it is more of a playfulness than anything else, that being in AI, we are kind of familiar with this, that you do data gathering from real world, then you do a model fitting, then you do an analysis and insight, then you are supposed to do removable observer bias, and then you get a payoff. And I was reading somewhere else, and it seemed to me it pretty much matches this prescription which was there with us all along as human beings. You are supposed to first go after Gyan, then you are supposed to go after Bhakti, and I always wondered, why would you need Bhakti after you've got Gyan? But then when I thought about it, no matter how much of data you get from the real world, eventually your analytic model fit is always an act of belief. I might have gotten 4 points like this, but to say that it is a straight line, I don't have every point here. So I believe that the straight line is what it is. So yes, there is an act of belief, and it is perhaps good that we understand that when we are doing this model fitting step as the output of a learning process, there is an act of belief which might need to be tested or to be kept in mind that it could have been different. We just didn't ask for it. So when we got the initial data with Newtonian mechanics, we were happy. Then Mercury had a irregularity in its orbits, and then we decided, oh, sorry, there's something wrong with it. General theory is where it is. That happens. Just doing that, you have not created anything new. So typically you do need this analysis and insight to really have a payoff. Now you understand something about the world. If this is the model, then this is what must have been happening in the physics or happening in the other human being's mind. But if you have done all of that and you've come to some conclusion, how do you know the conclusion is not an artifact of what you did with respect to your model fitting and data gathering in the first place? So the observer bias is very much there. So your process of using your brain to do Gyan and Bhakti and Chaitanya is always likely to have been affected by your ego. And so there was actually a prescription that you are supposed to, after that, shoot for Vairagya. I never understood why that thing came, till finally I said, okay, well, maybe this is what it was. And yes, after that, there was Ananda here and payoff there. So hopefully we'll all get there, AI and humans included. Thank you. So this was just instead of a thank you, I thought I'll say this. Given all the pitfalls and challenges, as human beings, do we really have an option of ducking AI? I don't believe so. So first of all, there's this quote by Einstein. A ship is always safe at port, but that is not the point of a ship. So you need to ask yourself, what was the point of the human race? Life was figured out long back. The crystallization from energy into particles happened even way back and all of that. We pride ourselves with our intelligence. So the one thing that we have done new is we have managed to create intelligence independent of life. And that has its consequences, because life has limitations which intelligence may not. So as a fanciful way of looking at it, maybe that's where the ship needs to be sent out into the sea, storms and waves notwithstanding. And there was another example that one of my seniors would give me whenever we would complain about the work we had to do. That there was a bunch of laborers working in some king's garden, something. And one of them was, with a very bad expression, breaking some rocks. And someone goes and says, what are you doing? He says, can't you see my cursed luck? Here I am under the hot sun, breaking rocks. This is what life has come to. Okay, sorry, that is what it is. He goes a little further, and there's another old man happily singing a tune and rhythmically breaking a rock. pretty happy with himself. So he says that, what are you doing? Hey, you don't see, I'm building that beautiful palace. So the perspective you bring to your work might change your emotional state and appetite for that work. So if you are going to be working in AI and dealing with all the brickbats, I think you need to get back to the first point and believe you are doing something worthwhile. Only then you will really take it on. Thank you.
Right. You only are now telling the third world or whatever that, see, when we did, the first world is telling now, when we did it, we produce all this, you don't produce. So what are that kind of, say, foresight in this particular area? Someone asked this technology.
So that's what I was saying. So if you do, see, I can think of, okay, here is a problem that I solve as a computer science algorithm problem, I go and solve it, great. When you're unleashing it into environments, now suddenly you have given somebody the power to, see, previously we used to have, let me give a concrete example. Previously we used to have something called a price list. This is the price. So it was meant to be according to the economic theory that you have two curves going and intersecting, that this is the payoff for the producer, this is the utility for the consumer, and where it goes and hits, that much will get produced, that much will get consumed, and there was a benefit on both sides. Great for that theory. But it assumed a discovery and a fixed price. Now suddenly you have gone ahead and unleashed AI, which allows a corporate to have differential pricing schemes. So as and when you have clicked on that product, they can actually give you whatever price they want. They are not required to repeat the same price for the next 1 month. You would not even expect it anymore. Right? Now, is that a good thing or a bad thing? So many of these things are unsettled. So it could be that it means that I'm able to more optimally utilize my resources. But optimal from whose point of view? Maybe I'm in a position to optimally exploit your gullibility and take you to the cleaners. So those are some of those aspects. Then secondly, it can change our attitude and behavior itself. And we don't know what social impact that will have. If AI is going to be answering a whole bunch of questions of the, see, previously we said that we don't want to bother doing numerical computation because anyway the calculator will do it. Then we said, okay, we don't want to really be bothered about solving differential equations because a CFD program will anyway give me the finite element method analysis. Today are we saying I don't even need to bother that textbook, ChatGPT will answer the question? See, you might laugh, you might not laugh. It might even be that fine, so I don't have to bother about it. Why should I bother about it? What was so necessary for me to bother about it? We never asked that question because we took it for granted that that is how things are. So we need to worry about it. Now, in engineering domains, at least I come from EE department, there was something called the small signal regime and the large signal regime. I don't know if it is still taught and how many of you are familiar with it. So if you have a small fluctuation in your gate voltage, there will be a corresponding fluctuation on the collector side. Now, in the small signal domain, it's a constant multiplication that is going on. Millivolt here, you will get a half a volt there. Sine wave is sine wave. But obviously, when you make it a big signal, at some point you'll hit VDD and ground, and you will have to have a cutoff. So anything that we do as human beings, when we initially introduce it, we are always looking at the benefit from the small signal modulation. That a little bit of AI, a little bit of automation, a little bit of capitalism, a little bit of structured farming, great. But then we take it to the extreme. See, it is not as if the first time humans being cleaned up 2 acres and planted some rice, anything went wrong. But today, if you are burning down the Amazon forest, something is going wrong. So the small signal being beneficial is not equal to the large signal being sustainable. And that story has repeated itself across everything. I mean, for all our talk about learning systems, we humans never learned that lesson. So for every disruptive change, we have always gone gung-ho because the small signal implementation gave us a lot of payoffs. But then, as you say, where is the discipline to say that everybody will not jump in and make it a large signal? I don't see it happening so easily for this either.
Hello, sir, here. First of all, sir, thanks for the wonderful presentation. This is probably the best I have seen on AI topic. And my question is related to the future of AI in war technology. Because we have seen war between Ukraine and Russia, And although Russia, it's a high-tech army with, it's touted to be AI-enabled, but it's not doing that well against Ukraine. So what is your perspective on that? Thank you.
Have you read those Harry Potter books?
Yes, some.
Okay. So I think in the 6th book or something like that, there is this iconic scene where the Minister of Magic and somebody else is briefing the Prime Minister. And they are saying, the bad guy is using magic to, there was something or the other going on. Some breakdown, tod for killing something. So he says, but you guys are magicians, can't you all fix it? And they gave him an incredulous look and say, surely you realize, Prime Minister, the other guy has magic too. So, is AI being used in warfare is one question. Is that the defining output factor in this case is a completely different question. There is nothing to say that both sides don't have it, or in any case, if one side had it, the other side had it supplied by their benefactor. So, I'm not sure that sitting as an armchair analyst, we can say anything about that. The next thing is with respect to use of AI in warfare. Again, a huge concern is always expressed. The reality on ground is something else. If it came to something like nuclear weapons, they had such a huge footprint in the physical world. Building a centrifuge for refinement was a massive endeavor. You can't hide it so easily. And you cannot fake it. It needs real science, technology, industry, capital, everything else. So you could actually come up with a control regime which said that only the following countries will have it, the rest of them, if they are detected, will be shut down and blah, blah, blah. And fine, yes, little by little, even that has started opening up, but not that much. It has not opened up a floodgate. Fine. Initially it was 2, then it became 5, then it became 5 plus 2, and might have gone to 8 or 9. That's about it. Okay. AI is unfortunately not like that. Again, as I'm saying, the spectacular examples of AI, let's say a Chat GPT or a Google search engine or AlphaMind, they may be a few big things. But in reality, AI that is hitting our lives is in very small pieces all over the place. Can you prevent those small pieces also going into the defense space? You pretty much cannot. So, can I put a complete line saying that AI shall not be used for defense? I don't even know what it means to say that. Surely it will be there on his desktop, surely it will be there on his cell phone. It will be there in so many different places. At what point do you therefore draw the line and say, okay, this you are not supposed to do? So eventually it comes to accountability. Now, if it comes to accountability, what it means is somebody has to be sure what the AI is doing to the same extent that the general is sure what his soldiers are doing. If the soldiers go and commit a war crime, it's a failure of command control, the general and the political leadership would be liable. But yes, those individual soldiers are also liable. Beyond that, what? So you have a huge training and supervision mechanism to make sure that the individuals under the stress of the moment don't lose it and act in an unprofessional way. At most you can hope for that those kinds of controls will be there. But did human beings not go and put bombs on other human beings? They did. So you can't say that the AI is the only reason that some civilians are getting bombed. Civilians were getting bombed by human beings all along. Sad, but true. So it's not at all clear that it is possible to stop it, however desirable it might intuitively be to do so.
Last question.
Thanks a lot for the excellent talk, sir. My question was connecting both the points. So in the beginning, for example, we discussed how AI for sure is being built for the benefits of some, right? So the technology is being designed for the benefits of some. And in the end, we also discussed how it is having indirect consequences on, let's say, kids and children. So how do we make sure that it at least is beneficial and doesn't do harm and so on?
As an assurance case, you can't. But collectively, as adults, we are typically responsible for the next generation. As a much older person, I can tell you that parenting is always good wishes and best effort. No matter how much we may have given you an impression when you were a kid that we absolutely knew what was going on, we never did. And with each generation, the ability of parents to reach back to their childhood days to therefore decide how they should reach their kids. If you were to look upon that as a safety factor, the only thing we could do is to say you shall not make more than this amount of progress generation to generation, so that my childhood is still relevant when I'm trying to raise my kid. The way things are going now, it's breaking down. On the dark side, what it might mean is that we are no longer able to ensure that safety. So it will lead to some amount of chaos. So for all the wrong reasons, because of a crash, the rate of progress will necessarily slow down to the point where we are back into the safe regime. If you have to live and learn that way and one generation, but I think they are a spoiled generation, so I won't feel very sorry for them.
Thank you.
I hope I was not too harsh.
Thank you for a wonderful talk, sir. Now I invite all the three sitting in the front row, Professor Das sir, Dean sir and RC sir, to give the mementos to the guest. Thank you.